Hello and namaste. Welcome to chapter 4 of Applied Mechanics, Center of Gravity, Centroid, and Moment of Inertia. That is the part of our Applied Mechanics course. I'm Assistant Professor Sunil Rakhal from Institute of Engineering, Tribhuvan University, Nepal. Today we'll delve into the fundamental concept and practical applications of these crucial engineering principles. Certainly, here are some specific learning objectives for the section titled Concept and Calculation of Center of Gravity and Centroid. Students will able to define the term center of gravity and centroid accurately, distinguishing between the two concepts and understanding their significance in various engineering and physics contexts. Students should be able to identify the center of gravity and centroid for a simple geometrical shape. Students should able to determine the centroid of composite area. Students will develop proficiency in calculating the centroid using appropriate mathematical techniques such as integration for irregular shapes or geometrical formula for regular shape. Students will be able to apply the concept of center of gravity and centroid to solve real world engineering problem such as determining the stability of structures, designing mechanical systems, or analyzing the balance of object. Students will be able to analyze complex scenario and apply the principle of center of gravity and centroid to solve problem related to equilibrium, stability, etc. By achieving these learning objectives, students will gain a comprehensive understanding of the concept of center of gravity and centroid as well as the skills necessary to apply them confidently to various engineering and physics problem. We'll begin with center of gravity. Centroid and moment of inertia. So first of all, the concept of center of gravity. Center of gravity of a body is the point through which its entire weight can be assumed to act. It's crucial in understanding the equilibrium and stability of objects. For instance, when a string hangs at the CG of rod, it achieves balances. Thus, center of gravity of the body may be defined as the point through which the whole weight or resultant of a body may be assumed to act. It is denoted by Cg or G. It is related to concentration of whole weight of the body. I have already said when the string is in the center of gravity of the rod, then it is balanced. If you see in this figure, this is the point that is called Cg. This mass is equals to this mass, or in another way, we can say this is the point of mass balance point. Whereas the centroid or center of area is defined as the point where the whole area of the figure is assumed to be concentrated, or it is stable assumed center point of the plane area. Center of gravity consider the weight of the body or mass of the body, whereas centroid consider the area of the body. In centroid, the area is assumed to be concentrated, or stable assumed center point of the plane area is known as centroid. This is the point of centroid. For the determination of centroid of the composite area, let us consider a whole area. Let us consider a whole area A, and the area is divided into smaller area, that is A1, A2, A3 AN. When x1, x2 and x3 be the horizontal distance from the assumed reference y-axis, that is the assumed reference y-axis is this axis, and this is the assumed reference x-axis, this is the assumed reference y-axis. So this is the distance x1, this is the distance x2, this is the distance x3, and this is the distance xn. Means x1, x2, x3 xn be the horizontal distance from the assumed reference y-axis to the centroid of the individual figure. Here individual figure means A1, area of figure A1, A2, A3, A4. And y1, y2, y3 be the vertical distance from the assumed reference x-axis to the centroid of the individual figure. If the last figure have centroid and the centroidal distance be xn and yn from y-axis and x-axis respectively. So if the third figure have the centroid in this point and y3 with the distance from the x-axis to the centroid of the third figure. So we know the whole area into centroidal distance of whole figure is equals to sum of area of individual figure into individual centroidal distance from the same axis. So we have whole area is equals to A1 plus A2 plus A3 plus AN, and centroidal distance of whole figure means x bar. X bar is the centroid of whole figure or centroidal distance of whole figure from reference y-axis. This is x bar. So whole area into centroidal distance of whole figure is equals to sum of area of individual figure. Area of individual figure means A1, A2, A3, A4, area of individual figure into individual centroidal distance from the same axis. Individual centroidal distance means centroid of the first figure, centroid of the second figure, centroid of the third figure, and so on. That's why sum of A1x1 plus A2x2 plus A3x3 and ANxn. So from here we derive the formula for x bar, that is equals to A1x1 plus A2x2 plus A3x3 plus ANxn by A1 plus A2 plus A3 plus AN, where x bar is the centroidal horizontal distance from assumed reference y-axis to the centroid of the whole figure. If the centroid of the whole figure is in this point, then x bar be the centroidal distance from reference y-axis and y bar is the centroidal y distance from reference x-axis. And in similar way we can determine the y bar of the figure. So y bar is the centroidal distance from the reference y-axis that is a1y1 plus a2y2 plus a3y3 plus dot 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 divided by a1 plus a2 plus a3 plus dot 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 an. An means the area of last figure, means n figure, and for the CG, moments are taken of masses rather than of areas of individual parts of the solids. The CG will then have the coordinates of x bar is equals to m1 x1 plus m2 x2 plus m3 x3 plus dot 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 upon m1 plus m2 plus m3. That means summation of mi xy divided by summation of mi. This is the formula of x bar. If we calculate the center of gravity Cg, where m is the mass of body, mi is the mass of ith body or ith part. In similar way, y bar is equals to summation of mi yi divided by summation mi. That means y bar is equals to m1 y1 plus m2 y2 plus dot 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 divided by y1 plus y2, sorry, divided by m1 plus m2 plus m3 plus dot dot dot. If all the sections are of same material having density rho, then m1 means rho v1, rho is the density which is similar, and m2 is equals to rho v2 and m3 is equal to rho v3 and so on. In the volume of the whole figure, v is equals to sum of individual figures. So v is equals to v1 plus v2 plus v3 plus dot dot dot. And from this, x bar is equals to summation of b xi divided by summation b, and y bar is equals to summation b into yi divided by summation b. That means summation of bxi means we know the formula of m1, that is m1 is equals to rho v1, and this rho v1, rho v2, rho v3 is taken in this equation and taken in this formula. So mi means m1, m2, m3 means rho v1, rho v2, rho v3, and finally rho is constant and taken outside of the summation, and numerator rho and denominator rho cancel each other. So final formula of x bar is like that. And when we consider the area A and the thickness of the plate T, that means volume is equals to area times T, and the thickness is constant for all the body, means the same body. Means if we consider this plate and having a1, a2, a3, a4, and the thickness of this body is same, that means finally this formula is reduced in the form of above formula, that is x bar is equals to summation of a1 x1 divided by summation of a. So this is the final form of the x bar and the y bar. And after knowing the formula of x bar and y bar, we will discuss Here the term centroidal axis, reference axis and symmetrical axis. The axis which passes through centroid of the given figure is known as centroidal axis. The axis which passes through the centroid of the given axis, centroid of the given figure. We consider this figure and this is the point centroid, and the axis passes through this centroid which is parallel to x-axis, then it is called the centroidal x-axis, and this is the point centroid, and the axis which is passes through this point and parallel to y-axis is called y, that means centroidal y-axis. This is the centroidal axis. And reference axis are the axis with respect to which the centroid of the given figure is determined. That means if we consider this rectangular plate having area A and the centroid of the rectangular plate is this point, so it means this is the coordinate of centroid, that means x bar, and this is the coordinate of centroid y bar, and the centroid of the figure O B C D is equals to x bar comma y bar. This x bar is taken from the reference y-axis and this y bar is taken from the reference x-axis. So reference x-axis are the axes with respect to which the centroid of the given figure is determined. If this reference y-axis is shifted from here and centroid of the rectangular figure from this shifted y-axis, y dash axis is x bar plus, and this is the distance b a, means x bar plus a is the centroidal distance from the reference y dash axis. So this is the reference axis. After knowing the reference axis, we have to know symmetrical axis. Symmetrical axis is the axis which divides the whole figure into equal parts. That means in this figure, this y axis is the symmetrical axis because this y axis divides the whole figure into two equal same part. But here in this figure the x axis is not a symmetrical axis because this x axis does not divides the whole figure into two equal parts. So we conclude that this y axis is symmetrical axis and x axis is not the symmetrical axis. So we can say for a figure which is symmetrical about both axes, means if we consider this rectangle, this axis divides the whole figure into two equal parts and this axis also divide the whole figure into two equal parts, means mirror image, then the centroid always lies at the intersecting of these two axes, means centroid always lies in intersecting of both symmetrical axes, or we can say centroid lies at symmetrical axis. For a figure which is symmetrical about both the axes, means x bar is equals to 0 and y bar is equals to 0. means this is the centroid of this rectangle, and x bar is equal to 0 and y bar is equal to 0. It means if the reference axis from here, then you can say x bar is equals to 0 and y bar is equals to 0. In the same way, for a figure which is symmetrical about the y axis, means x bar is equals to 0. It means the centroid of this figure lies at this y axis, means a reference axis is same as symmetrical axis. So you can say x bar is equal to 0. That means x bar is the distance of the centroid from the reference y axis. In the reference y axis is considered from centroidal axis. That means the centroidal distance from this axis is 0. Note, the area on the left side of the symmetrical y axis is equal to the area on the right side of the y axis. Means if we consider a symmetrical axis, or if this is the symmetrical axis, then it divides the whole figure into two equal parts. That means this is the area of the right side part, that is A1, and this is the area of the left side, that is also A1. So these area are equal if the y axis is symmetrical axis. So by the same way, for a figure which is symmetrical about x axis, y bar is equals to 0. That means symmetrical about x axis means this is the symmetrical axis and the centroid lies at this axis, means y bar is equals to 0 because the reference line is also in this x axis. So the distance from the centroid from reference x axis is 0. But if we assume the reference axis from the bottom, then we cannot say this distance is equals to 0. This is y bar. But we know the centroid lie at this symmetrical axis. For a figure which does not have any axis of symmetry, we calculate both centroidal x and y axis. We cannot say directly the centroidal distance of the figure. Here are the position of centroid of plane geometrical figures. These centroidal value of the geometrical figure is first obtained by integration method, and these values will always same because these are the geometrical figure. So we first know the value of centroid of the plane geometrical figure. First we can see here the figure of rectangle, that is the base of the rectangle is b and height h. The area of this rectangle will be b into h, that means base into height, and the centroidal x distance means x bar, that is equals to b by 2, means the centroid of the rectangle lies in these points, so that x bar is equals to the b by 2, means x bar that is equals to b by 2, and y bar means the distance from the reference x axis to the centroid of the given figure. That means y bar that is equals to the h by 2. And another figure is rectangle having base b and height h. So the area of the rectangle is 1 by 2 base into height, and the centroidal x distance is b by 3 and centroidal y distance is h by 3. B by 3 means if we consider the reference axis is like that, and this is the centroidal x distance, that means x bar that is equals to b by 3. If you move from this point, the distance from this point, the distance will be 2b by 3. This distance is 2b by 3 and this distance is b by 3, that means overall distance is b, and y bar is equals to h by 3. And if you orient the triangle in this way and consider a reference axis is like this, and this is the reference axis x, so you can say this is the centroidal x distance, that means 2b by 3, and from reference x axis the centroidal y distance be h by 3. And for the circle, the area of circle be pi r square if the circle having radius r, and the centroid of the circle is in center. That means if we consider a reference axis from this is the centroidal y distance, this is called y bar, and this is the centroidal x distance is equals to x bar is equals to radius r, and y bar is equals to radius r. If we consider a semicircle, the area of semicircle be pi r square by 2 if this semicircle having radius r and the area is pi r square by 2, and x bar be the centroidal x distance, that is r, and the y bar is the centroidal y distance, y bar this is equals to 4r by 3 pi. This 4r by 3 pi is first derived from the integration method, and the value of this 4r by 3 pi always same. That means in geometrical figure, the centroid of the geometrical figure is always same. That means this formula is applicable in practical field. This is the standard formula of this standard figure. That's why we remember this formula for the application field. And if we orient this semicircle in that way, area will be same pi r square by 2, and the centroidal x distance, that is this is the centroidal x distance, and this is equals to 4r by 3 pi, and this is the centroidal y distance, means centroidal y distance is y bar, that is equals to radius r. If we take the reference axis is like that, the centroid of this circle will be 0, 0, means x bar and y bar lies at this center point. So x bar is equals to 0 and y bar is equals to 0. If we consider the semicircle by this way, the area of centroid will be same, and the centroidal distance x bar means 0. That means the reference y axis lies at the centroid, that means centroidal y axis lies at this point, that means the distance from the reference y-axis is 0, and if we consider the x-axis at the bottom, so y bar is the distance from the reference x-axis, that means 4r by 3 pi. And if you consider a quarter circle having radius r, the centroid lies at this point, that means this x bar is equals to 4r by 3 pi, and this y bar is equals to 4r by 3 pi. And finally, the centroid of the trapezium is a square plus b square plus ab by 3a plus b, and the centroidal y distance, that means centroidal y distance means y bar, that is equals to 2a plus b into s divided by 3a plus b. These are the standard centroidal distance of the standard figures, which is always same. We will delve into practical examples such as determining the centroid of right angle triangle by method of integration to find the centroid coordinates or centroidal coordinates. So we consider first the right angle triangle. In that way, the right angle triangle having base b and height h, and first of all, if we consider the strip that is parallel to y-axis and the height of this axis be y. So first we determine the equation of this line. That's why we consider the similar triangle property. In that triangle, that means h by b. If we consider true triangle, that is triangle b d and a, and another triangle means small a, small d and a. In triangle small a, d and a, this two triangle we apply similar triangle property, so that overall height h divided by overall base b in the big triangle. And if we consider this small triangle, small height is AD, that means y divided by this distance, means overall distance is b, and from the reference y-axis to this strip is x, means this is the distance b minus x. That's why y upon b minus x. From here we develop a equation y is equals to h by b into b minus x. This is the equation of this inclined line. If the question give this equation, so we don't need to determine this equation. So here question doesn't give the equation of this line, so we first determine the equation of this line. So after determining the equation of these lines, taking vertical strip parallel to y-axis having width dx, we consider this vertical strip that is parallel to y-axis and having small width dx. This is very small width as compared to others. So we first find the area of the triangle. That means area is equals to integration of this small area dA, small strip dA. if we consider for this small strip and integrate them to find the area of the whole figure. That's why overall area A is equals to integration of this small strip area dA. For small strip area, the height of the small strip be y and the width of this small strip be dx. So area of small strip dA is equals to y times dx, y times dx. The integration is done by dx, that's why the limit of x is assigned in this limit integration. That's why limit of x from 0 to b in x-axis, that's why 0 to b, and the value of y is taken from above, that is y is equals to s by b into b minus x, and dx into dx, this is same. And from this, s by is taken outside of this integrating, and inner term is integrated by dx, that's why bx minus x square by 2, and take a limit 0 to b of this, and finally we can calculate the area of this triangle be 1 by 2 b into h. The area of triangle is 1 by 2 b into h. We determine the area of triangle by integration method. For the determination of centroid, we first calculate the area, because the centroidal distance, for the calculation of centroidal distance, we need to calculate area first. After calculating this area, we then move to calculation of centroid. The centroid x bar is equals to 1 by a x e dA. This is the formula of the centroid. This is the composite formula, means x bar is the centroid of the whole figure times a, means whole area times centroid of the whole figure is equals to sum of the individual figures, means xc, that is equals to centroidal distance of strip xc, and area of individual, that is equals to area of strip, that is dA. And integrating one, like both are same, this is the summation of individual area times individual centroidal distance, that is equals to whole area times centroidal distance of whole figure. So this is the formula for integration. From here we can derive this formula, x bar is equals to 1 by a xc into dA, and from this area we have already determined bh by 2, that means 1 by bh by 2 means 2 by bh times integration xc dA, that means dA is the area of this strip, that is equals to y times dx, y times dx be the area of strip, and this xc is equals to x, that means xc is the distance of the centroid of this strip from the reference y axis, that is equals to x, means this point can be plot by taking the value of x and value of y. And we can say in another way, if we take a strip In that point, this means this is the distance x and this is the distance y for this point. So here the strip is in that point, that's why the distance be x and y. That means xe be the distance of centroid of this strip from reference y axis is equals to x. So replace the value of xe, that is equals to x. From here the value of y is taken from above. So the equation is like that. Integrate by dx, that's why the limit of x will be 0 to b, that means 0 to b. And after integrating this inner side part, bx square by 2 minus x cube by 3, and we take the lower limit and upper limit and assign this upper limit and lower limit in this equation. We can calculate the centroid x bar. In that way, x bar be the b by 3, which is already taken in above table. X bar is equals to b by 3, that is the centroid of the right angle triangle, which is always same for the geometrical figure, that is in triangle, b by 3. And this is the centroidal x bar. We can go further for the centroidal y distance, that is for y bar. For y bar, we have the formula y bar is equals to 1 by a integration y dA. This is the formula which is similar to y bar times a is equals to summation of yi ai, which is similar to composite formula. Means here y1, y2, y3 is ye, that means ye is the centroidal distance of this strip and dA is the area of that strip, and this ye and dA, the product of ye and dA, by integrating them, this is equals to y bar times a. From here we derive the formula for y bar. Y bar is equals to 1 by a ye dA, and dA is the area of this strip. Area of this strip is height means y and width means dx, y into dx. So area of this strip is y dx. So y dx is the area of strip dA. In the formula, ye means the centroidal distance or centroid of the strip from the reference x-axis, that is ye. So ye is equals to y by 2, because the height of the strip is y and centroid of this rectangular strip be y by 2 from the reference x-axis. That's why replacing factor of ye is y by 2. In vertical strip, in above, for calculating x bar, if see there, you see there, this vertical strip xc is the distance from y axis, in the vertical axis, in the vertical strip, x is equals to x, because the strip is very small in x direction, but the height of the strip be y. So the centroid of this point from reference x-axis be ye, that is equals to y by 2. So replacing factor of ye is equals to y by 2, and dA is the area of strip, which is equals to y dx. The integration is done by dx, so that the limit is taken of x, that means 0 to b, that is strip expand from 0 to b. That's why 0 to b is the limit of this integration. So from here, y square into dx 0 to b, integrating factor is dx and the value is y square. That's why replace the y square in terms of dx from above equation. That's why y is equals to s by b times b minus x. That's why y square is equals to h square by b square, b minus x whole square dx. So from here, b minus x square is equals to b square minus 2bx plus b square times dx, and h square by b square is taken out from this limit integration, and first this integrate this and taking the limit of this integration 0 to b, 0 is lower limit and b is the upper limit. By putting this upper limit and lower limit value, we can calculate the y bar, that is equals to h by 3. This is the centroidal y distance of this right angle triangle, which is h by 3. And finally we can say the centroid of the right angle triangle be b by 3, that is equals to x bar, and h by 3, that is equals to y bar of the right angle triangle. This is the known centroidal distance of the right angle triangle. So this centroidal distance b by 3 and s by 3 of right angle triangle is always same, but the orientation is like that. You can take any strip for the determination of centroid, but one thing keep in mind, the replacement distance of these be ye and xe should be exact. That means, for examples, if we take vertical strip that is parallel to y axis, ye is the distance of the centroid of the strip from the reference axis. That means ye is equals to y by 2, according to this assumption of formation of this strip. By this way, you can determine the centroid of the non-geometrical figure. That means curve figure, you can calculate, you can determine the centroid by this integration method. So another examples involves locating the centroid of a complex figure. There is the question for locating the centroid. This is the combination of one or more figures. So first, divide the whole figure into known geometrical shape. That means one is a rectangle, that means 7 by 7, the dimension of this rectangle 7 by 7, and number 2 is quarter circle with 7 centimeter radius, which is positive. This is the 2-number figure. And third number is triangle. Fourth is rectangle. The dimension of this rectangle be 7 cm into 4 cm, that is number 4 in that way. And number 5 is rectangle 4 cm into 3 cm. This is the number 5. And finally the circle with 6 cm diameter, which is negative, because question asks for us locate the centroid of this shaded area. Locate the centroid of this shaded area means this 6 cm diameter circle is removed from the shaded area. That's why this is a negative and other part is positive. You can divide the figure in your own way. You can take this rectangle in numbering 2 or 3 as you like. You can numbering in your own way. So first, for the determination of the centroid of the whole figure, we have one standard formula, that is equals to x bar is equals to a1 x1 plus a2 x2 plus dot 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 divided by a1 plus a2 plus dot dot dot. That's why we first calculate the area of this individual figure and centroidal distance of this individual figure. So we first calculate the area of the rectangle, that is 7 into 7, that is 49 centimeter square. This is first rectangle, and x1 be the centroidal distance of this rectangle. So this is the reference y-axis, and the centroid of this rectangle is b by 2 and h by 2, which have already known. The formula of this rectangle we have discussed earlier. That's why this is the centroid of the rectangle. That means x1 is equals to 7 by 2, that is equals to 3.5, and y1 is the centroidal distance of this rectangle from reference x-axis. That means if the reference x-axis is in the bottom of the rectangle, then this centroidal distance be h by 2. But here the reference axis is bottom of the whole figure. That's why centroid of the rectangle is here, and this is the distance of this centroid from reference x-axis. That's why this is called y1, and y1 is equals to sum of this distance and this distance. That's why if the reference axis is bottom of the bottom of this rectangle, then centroid be h by 2, that is 7 by 2, that is 7 by 2. This is the distance of the centroid of the rectangle is 7 by 2, and this y1 means the centroidal distance from reference x-axis, that is equals to y1, which is equals to this distance plus this distance. That's why 7 by 2 plus 7 is the bottom distance. This is also 7, that means 4 plus 3 is equals to 7. So the centroidal distance of this rectangle y1 is equals to 10.5. So for the second number figure, that is quarter circle with radius 7 centimeter, the area of this quarter circle be pi r square by 7. R is the radius of this quarter circle. x2 is the distance from reference y-axis to the centroid of this quarter. That means x2 is equals to 7 plus 4r by 3 pi. If this quarter circle is like that, this is the centroidal distance, which is equals to 4r by 3 pi. If you take the reference axis from here, but the reference axis is far from this point, these lines, so 4r by 3 pi plus this distance means 7 plus 4r by 3 pi. 7 plus 4r by 3 pi, r is the radius, so x2 is equals to 9.97 cm. And y2 is equals to the centroid of the figure 2, which is from reference x-axis, that is y2, which is equals to, this is the distance 7, 3 plus 4 7, and this distance will equal to 4r by 3 pi, because we know if we take this reference axis from the bottom of this quarter circle x, and this is the distance 4r by 3 pi. 4r by 3 pi plus 7, 4r by 3 pi plus 7 is the centroidal distance of this quarter circle. And third one is triangle. The orientation of this triangle in this way. The orientation of the triangle is in this way. That's why centroid of the triangle is the distance 2b by 3, and from here 2h by 3. That's why A3 is the area of the triangle 1 by 2 base into height. The base of the triangle be 7 and height of the triangle be 7. x3 is equals to 2b by 3, that's why 2 into 7 by 3, which is equals to 4.67, and y3 is the centroidal distance of this triangle, which is equals to 2 into h by 3, means 2 into 7 by 3, or you can write this distance is equals to 7, and from this base we move 7 by 3. So 7 minus 7 by 3, if we done 7 minus 7 by 3, means you move from reference x-axis to this centroid. That's why 7 minus 7 by 3 is also the centroidal distance, which is equals to the 2 into 7 by 3. And number 4, the area of the rectangle, 4 rectangle, means base and height. That's why 7 into 4, 28, and expo is the centroidal distance from reference y-axis. Expo is the distance of this centroid from reference y-axis. That's why this is the distance 7, and these are the 7 by 2. That's why 7 plus 7 by 2 is equals to 10.5. y4 is the centroidal distance of this point, which is equals to 3 plus 4 by 2 is equals to 5 cm. F5 is the area of figure 5, which is equals to base and height. The base is equals to 4 centimeter and height is equals to 3 centimeter, which is shown by this figure. Dimension is clear in this figure. So x5 is the centroidal x distance, means from reference y-axis to this centroid, that is equals to 7 plus 4 by 2, that is equals to 9. y5 means this distance equals to y5, that is equals to b by 2 means 3 by 2. And at last, the area of this circle is equals to pi r square. That means the radius of this circle be 3 pi r square is equals to 28.27 centimeter square, and the centroid of this circle means the distance from this reference y-axis to the centroid of this circle, that is equals to 7 centimeter, and the centroidal y distance, that is equals to y6, which is equals to 7 centimeter, that is given by the dimension of this figure. So after calculating all these parameter a1, a2, a3, a4, a5, a6, a7, we can calculate the x bar. We have the formula for x bar is equals to a1 x1 plus a2 x2 plus dot 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 a5 x5 minus a6 x6, because this 6 number figure is deduct from this shaded area. That's why minus a6 into x6 and divided by a1 plus a2 plus a3 plus a4 plus a5. These all are summation figure, adding figure, but the number 6 figure, that is equals to circle, and this is removed from this shaded area and taken negative in this formula before a6. So this is the composite formula of x bar. Take negative sign in that figure number which is removed from whole figure. So if we take a1 x1 a2 x2 in this formula, the centroid of the shaded area is equals to 7.06 centimeter. By this way, we have another formula, y bar is equals to a1 y1 plus a2 y2 dot 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 a5 y5 minus a6 y6, because the number 6 figure, which is circle, that is reduce or deduct from the overall figure. That's why negative sign before a6. After putting the value of a1 y1 in this equation and calculate them, the centroid of the figure, that is y bar, that is equals to 7.86 centimeter. By this way, you can determine the centroid of the composite area, but you remember the formula of individual composite figure, that means individual geometrical figure, that is standard figure. The formula of centroid is standard. The formula of this centroidal distance of this figure will be same. So this formula is applied to calculate the centroidal distance of overall figure. Here in this examples, the centroid will be 7.06 centimeter and 7.86 centimeter. If we consider this body, the centroidal y-axis means centroidal x distance is 7.06 cm, means from reference y-axis 7.06 centimeter is the distance of the centroid from reference y-axis, and y bar is equals to 7.86, means from reference x-axis this distance is 7.86. So centroid, this is the centroidal distance 7.06 and 7.86 from the reference x-axis and reference y-axis and reference x-axis respectively. So here are another examples for determine centroid of this curve figure by integration method, which is for you for the practice. And finally we have arrived at moment of inertia. This is for you. Finally we have arrived at moment of inertia, but in this session we just discuss the formula for moment of inertia and physical meaning of moment of inertia in bending, and later we will discuss in broad form in the next session. So by basic definition of moment of inertia, the cumulative product of area and square of its distance from an axis is called the moment of inertia of a section about that axis. That means Ix is equals to integration of y squared dA and Iy is equals to integration x squared dA. Ix is the moment of inertia of the figure about x-axis. Iy is the moment of inertia of the figure about y-axis, and y is the distance from reference x-axis. Y is the distance from reference x-axis to the elemental area dA, that is y, and x is the distance from the reference y-axis to the elemental area dA. So, or in other words, first moment of elemental area, that means moment of area means A times x, moment of force means F times d. So d is the distance, but here the distance is x, and in terms of force we assume area, we consider area. So first moment of elemental area about y axis means x into dA. This is the y axis, x is the distance, and elemental area dA. So this moment of area is x into dA, and first moment, that means second moment of elemental area, again this A into x is multiplied by x for the second moment of elemental area. Moment of moment, that means x square dA. So second moment of entire area A, with respect to y axis is obtained by integrating the above expression. That means this x squared dA is the second moment of elemental area, but we assign this integration, we have done this integration, we calculate Iy is equals to integration x squared dA. So second moment of entire area A with respect to y axis is obtained by integrating. So similarly for x-axis, Ix is equals to y squared dA, and the second moment of an area is termed as moment of inertia. So the moment of inertia about this y-axis is given by x square dA, integration x square dA, and moment of inertia about x-axis is given by integration y square dA. This is the formula for moment of inertia, and it gives the measure of resistance to bending of beams under the action of loads. That means the greater the second moment of area, that means greater the moment of inertia, greater the resistance to bending is equals to resistance to bending. Greater the second moment of area, that is greater the moment of inertia, greater the resistance to bending. So moment of inertia of cross section is essential for designing. This is the physical meaning of moment of inertia, and these are the references for detailed studies. And finally, thank you for this session.